The dream of multi-agent AI is incredibly appealing. You spin up a dozen specialized digital personas, architects, auditors, coders, and let them collaborate in real time to solve complex problems. But these systems are limited by a fixed context window. Every single thought, prompt, and output from every agent is funneled into the same memory container. We call this token bloat. In a shared window, for every one word of logic, the system often ingests 10 words of conversational history and administrative metadata. This noise eventually triggers hallucinations and memory drift, drowning out the agent's core instructions. As this noise-to-logic ratio grows, the local system eventually reaches its hardware limits and crashes, effectively ending the multi-agent collaboration. Sustaining a local system requires moving away from the idea of seamless connection. Instead, the architecture must enforce absolute separation. This is the core operating philosophy of the multi-file database, or MFDB architecture. We call it structural blindness. By severing the communication lines, the system isolates each agent into its own perfectly bordered cubic block. Hiding the administrative load from the agents is what enables local AI coordination to function without immediate system failure. At the top of this hierarchy sits the coordinator, acting as the master node. It holds the authoritative registry and acts as the absolute source of truth for the ecosystem. The coordinator manages its agents using a rigid data format called a BJSON manifest. This tabular structure defines an AI profile through 24 specific fields. While the coordinator retains full visibility, it strictly forbids any worker note from reading the historical archives. The coordinator maintains control by enforcing these rigid data structures rather than trying to manage the agent's active thought processes. This raises a technical hurdle. If the worker agents are structurally blind and they cannot use a standard shared API, how does the master actually dispatch a task? Communication happens through a unidirectional drop zone. This is a local execution folder physically separated from the master's core file system. The master formats a task document and uses an atomic file swap to place it directly into the worker's drop zone. This ensures the worker never reads a corrupted file, seeing the document only the millisecond it is completed. Once the siloed worker node wakes up, it reads the drop zone file and executes the task in a temporary bubble. We call this job-scoped amnesia. The worker has no memory of the master or any previous execution cycles. Physically isolating the execution environment guarantees a zero bloat workspace. It eliminates context drift because there is no historical memory to pull from. When the worker finishes its task, or its temporary working memory hits its maximum row limit, it begins the return journey. This is the log distillation protocol. The worker autonomously slices down its conversational overflow, compressing hundreds of lines of execution logs into a single, highly dense summary block, then pushes it back up to a designated polling directory at the master level. This autonomous truncation acts as a firewall. The master is shielded from ingesting the useless conversational bloat generated during the worker's execution phase. That brings us to the final phase, the rebirth cycle. The master node sweeps its polling directory to collect those distilled recaps. The dense summary block snaps directly into the master's tabular grid. The master updates its global state while keeping its own total token usage lean. This creates an interlocking clockwork mechanism that can run indefinitely without hitting the memory walls of traditional shared systems. System performance in these environments scales through the imposition of absolute constraints. By enforcing strict tabular formats, unidirectional drop zones, and total structural blindness, this architecture achieves a state of perfect cubic isolation.